In this lesson, we're going to explore the benefits and usage of some of the core compute resources. If we go ahead and look again at what are those skills being assessed, we're now looking at this describe core resources available in Azure section. And now in this particular lesson, we're going to dive into VMs, app services, some of the container services and Azure Virtual Desktop. And then on some other videos as we go through, we'll look at these other core types of resource. So that's the goal of what we're going to actually look at. Now, if we think back in an earlier lesson, we kind of looked at the idea that there were different layers and there were different responsibilities when we thought about those different aspects of the system. Now, in all cases, no matter what, if we remember, the fabric, so the storage, the network, the compute, that was always the responsibility in the cloud of the cloud provider, i.e. Azure, as was the hypervisor. So no matter what service we're using, this is always the responsibility of Azure. But then remember, there were different types of service in the cloud. We could think about where there was IaaS, infrastructure as a service. And our big example there was, well, hey, it's a virtual machine. And in that case, the responsibility there was, remember, mine. So with IaaS, this was me. Me as the customer, this was all my responsibility. So let's start with the idea of a virtual machine. Now, as we talked about previously, a VM is really the idea that we have all of that hardware, that infrastructure, and we're virtualizing it. We're giving ourselves some portion of that underlying system. Now, if we look at just creating a VM just super quickly, so if we jump over, if we just go to the Azure portal, and I can think about, well, I'll just go to virtual machines, and I can say create a new virtual machine. We'll see, hey, we do this usual, remember everything has to live in a subscription and one and only one resource group. So we could pick an existing one, we could create a brand new one. It has a name, this is the name of the resource in Azure, not necessarily the name that has to be in the operating system running within it. It has to exist in a specific region, it can't span regions, it's a single resource. We had that idea of availability options. And then we have this idea of the image. Now there's Windows images, there's Linux images, and these are all coming from the Azure Marketplace. I could even upload my own custom image. And then we have this idea of a size. And there's a huge number. We can see these letters, D, B, D, C, E, F, D, all these different letters. And then within those letters, you have these numbers. D2, D4, D8, D16, with different amounts of CPU cores, different amounts of memory, and then some other aspects like storage performance, network performance. So we have these different numbers associated with, depending on the different type of VM, and then the particular size of the VM. So what's all that about? So I can think about, if a virtual machine is virtualizing the hardware, it has certain attributes. For example, I can think about that virtual machine has a certain number of virtual cores. When we think about kind of CPUs, it has a certain amount of memory. Then it has a certain storage performance. I can think in terms of maybe IOPS, in terms of throughput, and then there'd be network as well. There might be specialist services that have GPUs, that might have NVMe local storage, that have RDMA network adapters. But different types of workload need different ratios. For example, if I'm a database, I want a lot of memory compared to the number of virtual cores. Whereas if I'm a compute service doing processing, I might want more virtual cores compared to the amount of memory. Or it might be general purpose, and I want just a balanced mix. So often there's kind of this ratio of cores to memory, and then we have specialist types. And so that's why we have these different SKUs, these different types of virtual machines, because they have those different ratios. If we jump over, we can actually see Microsoft has a VM sizes site. And really what we're going to care about right now is this idea that there are these general purpose types of virtual machines, compute optimized, memory optimized, storage optimized, GPU, FPGA accelerated, which are programmable pieces of hardware, high performance, all these different types. And exactly as we just talked about, if I looked, for example, at a compute optimized, within that particular SKU, there are different sizes. We can see the number of, for example, CPUs increase, and then so does the memory. But a key point here is look at the ratio, 2 to 4. So for every one virtual CPU, really virtual core, I have 2 gigabytes of memory, because this is a compute optimized. If I looked at a general purpose, and I'll just pick one of the particular SKUs here, and now we looked, well, once again, we have the idea of vCPUs and memory, but now the ratio is 1 to 4. For every virtual core, I have 4 gigabytes of memory. And then we have the idea of memory optimized SKUs. And you're probably going to guess what we'll see here. Well, now the ratio is 1 to 8. So what we would do is we want to understand, well, what's the workload we have? What are the types of processing we have running? And then we'll pick the right SKU that gives us the right balance of cores and memory and maybe storage performance and network performance to make sure, hey, it's going to have the right portion for the workload we want to do. So we want to optimize our spend. What I don't want to do is pick the wrong type of VM and have a huge amount of memory idle or a huge amount of CPU idle. Remember, I pay for these things. So I want to make sure I optimize as much as possible. So we have these virtual machines we can create, and we kind of saw that experience of creating it. Now, remember I said previously, the thing about virtual machines is there's a whole set of other aspects that you're responsible for. The patching, the backup, the DR, the antivirus, the firewall. And although, yes, you're responsible for those things, as we go through and actually create virtual machines, we'll actually see there's options for a lot of these for things to help you. So if I jump over, for example, to management, there's actually aspects of this that can do things like, hey, auto shutdown. I can do things like, hey, look, enable disaster recovery. It's going to use Azure Site Recovery. Hey, automatically perform patching for me. And then there's a whole bunch of actual extensions that I can go through. And extensions add other functionality. For example, there's an extension that uses anti-malware. There are extensions from third parties. So although, yes, it's my responsibility, doesn't mean you're on your own. There are things to help you do that. So a virtual machine I think about as a building block. It's a great fit if I think about I have some existing workload maybe on premises, and I just want to move it to the cloud. Virtual machines can seem very familiar. It's the same concept. I have full access to everything inside that operating system. I can configure it however I want. If I want to do DR maybe from on-premises to the cloud, I'm probably going to do DR to a virtual machine. Many infrastructure services, if I'm a domain controller, maybe a file server, hey, I can use a VM for that. If I wanted to install and run my own database, I'm going to put that in a VM. But as we'll see, Azure has its own managed database services, which may be a better fit for us. So these are a good choice if I need management and direct access to the operating system. This is where these really play. Okay, so then we build on that. We have the idea that's a single instance of a resource, a virtual machine. But if we remember the idea of the cloud, we want to do that scaling capability. We want to scale out, i.e. horizontally, we add and remove instances. And most of the time for resiliency, we'll have multiple instances of a service. Well, I could manually create a whole bunch of VMs. I could maybe write some script to look at something and stop and start them. But why do that? A better option is we have something called a virtual machine scale set. So this is obviously building on top of virtual machines, but what this adds to the picture is now the idea is I specify a certain template. So this is a template of which operating system I want to use. I specify a configuration, i.e. the VM SKU, the size, extensions to add, and I can also specify scale. Now that scale can be things like a minimum number of instances, a maximum number of instances, but also auto scale criteria. If CPU is over 70% on average, add 2 instances. If it's less than 30%, remove an instance. If a queue depth is over 10, hey, add an instance. So with VM scale sets, it's actually going to go and create those virtual machines for me. And that's really a great solution when I do have, hey, I need multiple instances. I don't want to manually create those things. That's kind of an ugly thing. This would do it for me. So if I have a requirement of you need X number of virtual machines all configured identically, and you want to be able to have some scale conditions, chances are a virtual machine scale set is going to be your answer for that. Then there's also services like Azure Batch. If I have a large scale parallel workload or high performance computing, then Azure Batch can actually go and provision the virtual machines behind the scenes, and I can just submit a job. I can say, hey, I need this thing to run. Azure Batch will take care of all of that for me. I submit the job, it queues it up, it executes it. So for a really large scale execution, Azure Batch may be a good answer. So these are really playing in that IaaS space. That's really where they shine. Now, after IaaS, you start to get into the idea of PaaS. Remember that platform as a service. And this is not quite as black and white. Like often we will draw the line of the idea that, hey, I, for PaaS, no longer care about the OS or the runtime. That's completely managed for me. And it does depend a little bit. Because the first type of PaaS we're going to talk about is containers. Now, if I think about a VM virtualizes the hardware. It presents to me a virtual set of hardware, CPUs, memory, etc. With a container, it's virtualizing the operating system. So through various operating system components, it's going to have isolated namespaces. So I have isolated set of processes, isolated networking. I can have resource controls to control how much resource in terms of maybe a CPU and memory I can actually use. But it now lets me have multiple applications sharing an underlying container host, i.e. an OS instance. Now, because of that, I can create them much, much faster. A VM still has a certain amount of time it takes to start up because I have to create the virtual machine. I have to get the OS started up. It may take minutes. So it's still fast, but it's minutes. If I think, hey, these new microservices that I need to spring up something, perform a calculation, and then it deletes, minutes is way too long. I want to think sub-second. So containers can do that. It can spring up super, super fast, but we still have isolation in that user mode space. So these are fantastic for those microservices. Now, the way a container really works behind the scenes is I have the idea of a container image. So there's some container repository. So I can think about, hey, with containers, there's a container registry is the term we use. In that container registry, we have container images. And that image may actually be made up of multiple layers. It might be built off an OS layer and then a runtime layer, and then I actually get my application. So there's lots of layers inside there. But then to actually use that, we have to create a container. So that container will actually often run on a container host. So we provision a container host. So we create this idea of a sandbox. So when I think about a container, it's creating this sandbox, but it's creating it in an operating system. There's now a container runtime, like a hypervisor virtualizes the hardware, container runtime virtualizes the OS. So there is now this container runtime that creates these sandboxes. and this image runs inside it. So now that container is up and running. And the whole point is I can have lots of these sharing the same container runtime. So I have an underlying operating system, a container runtime, a set of management tools, and I'm running these images. That's what a container is. So I have multiple running on the same OS instance, our container host, but they have those isolated namespaces for the processes, for the networking and resource controls. And containers really are the future. If you look at a lot of things people are talking about for applications, it's, I want to use containers. So let's think about the services in Azure that work with containers. Now, absolutely, I could just spin up my own. I could create VMs, I could install a container runtime, and I could do everything myself. But there are actual services in Azure that really do this for us. So the first one we think about is Azure Container Instances. So we have this idea of ACI. And the reason I'm kind of drawing it at this layer is you still pick the container image. So that container image has an OS and a runtime. I'm not managing the operating system of the environment, but I still have a little bit of gray area that I pick the image which has an OS. There's a little bit of management I'm still performing. But I really am focusing on my application that I'm putting inside that image. So ACI is really designed, hey, I just have a container I need to run. Maybe a couple, I can group them together so they share a certain space. But with an Azure Container Instance, and we can go ahead and look at one of these, all I really have to do, so let's switch over to ACI. I don't say very much. I say, hey, I want to create a container instance. All I'm going to do at this point is, once again, you have to pick a resource group always. I would give it a name for my container. So I'll just say test container 1. Pick a region. There are images from the default registry, and these are showing me some of the default sample ones I could use. I can base it on Windows, notice, or Linux. Or maybe I've got my own container registry, which I have, and I could use an image that I've created. And then I pick a size. So remember that VM idea of a SKU and a size? Well, once again, these are kind of similar. It's giving me a certain amount of CPU cores and memory, but I get a lot of flexibility here because this is really a serverless solution. I'm not having to pick a VM and pay for it all the time. I'll just pay for when this container runs. And then I can integrate with a virtual network, or I can just have a public-facing endpoint. And then there's a few other advanced things, but we're not going to worry about that. So I really think about the idea of, with a container instance, it's just the idea that I want to run a certain container for a certain period of time and just pay for it while it's running. So my first Azure service when I think about containers is, hey, I use an Azure Container Instance. So if I saw a question, hey, you need to just run this image that exists, I just want to make it available, what could I use? Well, an Azure Container Instance. And again, if you had maybe two that need to share a space, you can create a container group. However, most of the time, we're going to have a more advanced scenario. I need an orchestration of the containers to handle how they're placed on multiple container hosts, to control richer networking, to control persistent storage connectivity, to maybe control some of the identities and other extensions and policies that I want to use. And so Kubernetes has really become the standard in orchestration for containers. Now, yes, I could again install Kubernetes myself in a whole bunch of virtual machines, but Azure has its own Kubernetes service. So the next thing we kind of have here is Azure Kubernetes Service, AKS. Now there's really two planes to think about with Kubernetes. There's a management plane, the control plane, and then there's this idea of kind of a data plane, or where I actually run my containers. With AKS, that management plane is fully managed. I don't really see it. It's off running somewhere. It doesn't running anything I can see in my subscription, but all of the components that make Kubernetes work, the API server, the schedulers, the etcd database, all of the other resource managers, they're all often running somewhere we don't see. What we see is, well, the containers have to run somewhere. So what it will do is it will create container hosts, nodes, in our subscription. And what it actually does, well, guess what it does for that data? It creates a VM scale set. So the nodes that will run the containers, AKS, for all of the node pools, it will create a VM scale set, which remember is built on VMs. I get to pick the size. I get to pick the SKU of that node pool. So again, understanding that core building block is really, really useful because it applies to so many things. So with Azure Kubernetes, we get that rich orchestration where I can have deployment YAML files, Helm charts. I can even use things like GitOps where it goes and fetches its configuration from a Git repository. I can do all of that with Azure Kubernetes Service. So Azure Kubernetes Service, hey, I need a full, rich, orchestrated environment, but I still want it to be fully managed. So all I really focus on is the idea of that deployment YAML file that defines what containers I want to actually run. And behind the scenes, it's going to go and create, hey, a whole bunch of nodes, which I can see, but I'm not really doing anything about them, where it will go and schedule the execution of containers. Now, it runs those containers in things called pods. You don't really have to worry about that. But that's where the containers, it's kind of an envelope for the container. That's the unit AKS uses. So I have this idea of pools where I'm actually going to run my containers. So if you see something like, hey, you want to run this rich container environment, I need auto scale, I need integration with networking, I need persistent storage. As soon as you see the word containers, chances are, unless it's you just need one or two, you're going to use AKS. That really is the answer. And then we get to things like Azure App Service. So then we have app services. App Services is all based around, and this was actually one of the original Azure services, I have something web-based. Now, it could just be a direct web application I actually want to run. It might be something like an API that I want to expose. It might be a mobile application. There are special features around iOS and Android for push notifications, using a custom social provider, whatever. But if I have any of those things, this is great. So I can think about, hey, I have something from the web. I want to expose an API. I have something mobile. And I just kind of have my application code. App Service is phenomenal. I'm really not worrying about anything. Now, I can actually run containers on App Service as well. We're not really going to focus on that. With an App Service, what I can actually do is I can pick, well, what is the runtime I want? It is, in an underlying way, it is still using VMs. What I pay for is the number and the SKU and size of the VMs that the App Service is using. I have zero access to it though. I can't configure things in that operating system the same way I can't configure things in the OS for AKS. Yes, they exist, but they are fully managed. I have zero access to those things. I might be able to get certain logging, maybe get certain output, but I can't go in. Microsoft are responsible for the OS in all of these things. But if we go and look at one of these, if I jump over and let's say App Service, an App Service actually runs in an App Service plan. But I'll just create a new App Service. And here you can see, hey, do I want to run some code? And it integrates really nicely with things like DevOps. So I can push to this very, very powerfully. Or I can actually, this is where I can say, well, actually, I just want to run a container. I can do Linux or Windows. But if I say code, I tell it what runtime stack. So although I don't have access to the OS, it has a lot of flexibility in what it actually supports. So I could write my application in any of these things and easily move it over. Now you can see, because I picked .NET, hey, do you want to be Windows or Linux? So .NET can actually run on either one, so I get to pick. So it depends on what I'm using. as to which operating system. Sometimes there's different stacks. So for Java, hey, I can use Java SE, JBoss, EAP7, or Tomcat. So if I had maybe a web application running on premises today on Tomcat, yes, today maybe it runs on a VM, but if I'm wanting to do a little bit of refactoring, well, maybe now I could run it on an app service. So I have a huge amount of choices in the runtime. Even though I have no access to the OS or the runtime, I still get to pick those things. But I don't have to worry about patching them or the security of them. That's just done for me by the app service. Now, another aspect to app services, this is where we really start to move up the chain, is actually we think, and I'm actually going to use a different color for this, we think of serverless. Now, the whole point of serverless is all of the things we have talked about so far. VMs and VM scale sets, that's obvious. We're talking about some unit of work we pay for. But as we saw, even AKS, we're going to have node pools, which we pick the SKU and the size. App service, when we create it, we pick the app service plan where we pick a SKU and a size, and it has things like auto scale and other, maybe deployment slots, other features. But I'm still paying for essentially units of VMs. Serverless, we don't. So serverless is still PaaS, but it's that highest level because we're not paying for any unit of VM. We pay for the work that is being done. Now, there's really two key types. We have functions and we have logic apps. And both of these can run in that consumption model where I just pay for what I'm using. But functions can also, if you had an app service plan, I can also execute them within an app service plan as well as part of an app service. So I do have that choice. So here I have some code that I want to run, and these are event driven. Something's going to happen that tells me to fire these things off. It could be, hey, something's written to a storage account. It could be I get a RESTful API call. It could be a timer event. And maybe I'm manually executing. Something triggers it to perform the work. Now with functions, I'm writing code. When I create a function, I am essentially going to give it some code. So if I say, hey, I want to create a new function app, what we're actually doing, you see I've got a number of different ones here. But if I create a new function app, notice once again, a function can run something from a container. Everything can be containers today. But I pick a runtime stack, so I could run it from .NET, Node.js, Python, Java, PowerShell core, or some custom handler, and I pick a version. So for me, I'm a big PowerShell person. So if I wanted to run a PowerShell script, maybe on a schedule or when some event happens, I could use a function for that. And then I'll just pay for it. So the point is here, I'm writing code. Logic apps, a big push around the idea of that kind of citizen developer, codeless solutions. So if I go and look at a logic app, this is a visual designer. And what we can do with logic apps, once again, there's some trigger, but these are more stateful. There's some flow that maintains state for that entire flow. And then they have these graphical designer to drag and drop different components. This is taking its time. Let's jump over and then come back. There we go. So you can see here, I've got this graphical flow. Hey, a blob is added, create a URI, call a HTTP call, and then delete the blob. So I'm just dragging and dropping these things on. But also, there are built-in templates. So let's actually scroll down some of the templates. Let's find something interesting and fun. Daily reminder. Hey, based on a schedule, then I want to send kind of an email. If a new file is created in Dropbox, copy it to OneDrive. Email yourself tweets that contain a certain keyword. So there's all these plugins that I can use. I just drag and drop these onto my canvas. So the whole goal around all of this is that I don't really need to be a developer to use these. So these are both serverless. So again, if you see this requirement, I need to perform this piece of work when something happens, and I want to minimize my cost and just pay for the work done. If I'm writing the code, Azure Functions. If the emphasis is on, hey, if someone tweets something or something drops and I don't want to have to code, instead I want to use built-in connectors, hey, Logic Apps are great for that. And then finally, and this isn't, I think, in the same realm as this, but it's being lumped in with the skills assessed in the same way, there's Azure Virtual Desktop. So all of these things, and the reason I think it's a little bit different, is all of these IaaS and PaaS, they're not delivering a business function. There's something that you build on. You are still responsible for your app. There's something I have to add on top. It doesn't deliver a business function. Imagine a scenario, I want remote desktops. From my machine, I want to remotely connect and get a full desktop, or maybe just an application published to me. Well, if you think about what is required for that experience, well, I have to have some idea of there's some machine running, some host that will actually serve up my desktop. Then there's actually a whole set of other management layer. I need things like a broker that's going to control, well, as users come in, which host do I actually connect them to? There's the idea of a remote desktop gateway, because I want to encapsulate that incoming RDP in something that can travel over the internet. So the RD gateway enables me to do that. There's other databases, there's feeds, there's web feeds that I can control. So there's all these different elements that I have to manage. I have to maintain these hosts. Maybe they're running servers, maybe they're running a client operating system, maybe there's a pool, maybe there's personal. So the whole point of this is Azure Virtual Desktop provides a complete managed solution. Just like AKS, I do not see this part. This management plane is all just done for me. What I get in my subscription are the hosts that people will actually connect to. And the reason we want them in our subscription is I could then connect them to like my virtual networks. I can connect them to other services. I can have the profiles mapped into it. So Azure Virtual Desktop is doing two things. It can provide me with a complete desktop experience. So a user gets like a full start button and then they run whatever they want, or it can actually publish particular applications. So here, maybe on a mobile device, it's super useful to just bring up a certain app. Or even, hey, I'm running a desktop and I want it seamlessly integrated with my main desktop. I can do that with Azure Virtual Desktop. So this is basically, think about it as like a desktop as a service offering. So those are available as well. You might hear the term Windows 365. That's an even simpler version where I don't worry about any of this anymore. I just pay on a per user basis to get a desktop in the cloud. It's always personal, it's linked one-to-one, and there's different SKUs, business and enterprise. Business goes up to 300 users and it's Azure AD joined. Enterprise is unlimited number of users. It can be Azure AD or regular AD joined, but it can integrate with your existing networks, and there's a whole set of richer functionality, custom images, but you might hear that term as well. But that's why I think about some of the key kind of services that we have. So we have VMs. I want to kind of lift and shift something. I need direct full access to the OS. Virtual machine scale sets. I need multiple of them to provide that service, but it's going to create them for me. If I have containers, if I just have one or two and I don't need any rich orchestration, I could use Azure Container Instances. If I want to be able to submit deployment, declarative files, and have rich networking and storage integration and extensions and policy, Azure Kubernetes services. And then we have Azure App Services, which run on app service plans, which can be web-based applications, APIs I want to be able to offer out there, mobile apps, increased functionality for notifications and other things. And then if I just want to be able to offer desktops or published applications, we have Azure Virtual Desktop.